Welcome back to the ZORI'S Physics and Mathematics live coaching. Friends, today we are going to see the question from exercise 1.3 of the question 5 and sub question is 6 here. In this question, we have given x to the power y which is equal to e raised to x minus y. Then show that dy upon dx it is equal to log x upon 1 plus log x bracket square. So see, first we have to write this x raised to y, it is equal to e raised to x minus y. This is given part. Now take a log. Taking log on both sides. So what happened? Log x raised to y is equal to log e raised to x minus y. So by the index rule of the log, we can write y into log x is equal to x minus y into log e. Now remember here, log e, it is 1. So this part become 1. Now we remain with only y into log x. It is equal to x minus y. Take this y to the left here. So we get y plus y into log x, that is equal to x. Now take y common here. So y in bracket 1 plus log x, and that is equal to x. After this, take this part to the denominator here. So we get y is equal to x upon 1 plus log x. Now here we have to differentiate this equation. So differentiate with respect to x. So dy upon dx it is equal to, derivative of this part is 1 plus log x into d by dx of x minus x into d by dx of 1 plus log x divided by 1 plus log x bracket square. Now solve this derivative here. So we have dy upon dx, it is equal to 1 plus log x, derivative of x is 1 here. Now minus this part become x here as it is. In bracket, derivative of 1, 0, derivative of log x, 1 upon x, total divided by 1 plus log x bracket square. Now it is equal to 1 plus log x minus x into 1 upon x divided by 1 plus log x bracket square. X cancel, minus 1 plus 1 cancel. So that is equal to log x upon 1 plus log x bracket square. Now here, the value of dy upon dx, it is equal to log x upon 1 plus log x bracket square is proved. Now see the next question, question number 7. If y is equal to square root of cos x plus square root of cos x plus square root of cos x plus dash 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 infinity. Then show that dy upon dx it is equal to sin x upon 1 minus 2y. So this is very easy question, important question. So very first we are taking this part below here. Therefore y is equal to square root of cos x plus square root of cos x plus square root of cos x plus dash 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 infinity. So first we are doing the square of this part. Let this is equation here 1 square both sides. As we square the both sides, so we have y square is equal to cos x plus square root of cos x plus square root of cos x plus dash 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 infinity. Now see, from equation 1, this part it is nothing but y. So from equation 1 we can write y square it is equal to cos x plus y. This whole part from equation 1 here, this is what? Y. Now at this stage take a derivative, differentiate. Differentiate with respect to x. Therefore d by dx of y square is equal to d by dx of cos x plus d by dx of y. Now the derivative of y square it is 2y into dy upon dx. Take this dy dx to the left. So minus dy upon dx it is equal to the derivative of cos x is minus sin x. Now take this part common here. So we have dy upon dx in bracket 2y minus 1 that is equal to minus sin x. Take this part to the denominator here by the cross multiplication. So dy upon dx it is equal to minus sin x divided by 2y minus 1. After this we are taking this negative term here below in the denominator and the signs are get reversed. So this minus make 2y minus and 1 plus. So we have dy upon dx it is equal to sin x upon 1 minus 2y and hence proved. Now look at the question number 8 here. If y is equal to square root of log x plus square root of log x plus square root of log x plus dash 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 infinity, then show that dy upon dx it is equal to 1 upon x in bracket 2y minus 1. So very first same pattern like before question here. So first we write y is equal to square root of log x plus square root of log x plus square root of log x plus dash 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 infinity. This part is a given. We say it is equation number 1. Now square both sides. Square both sides. As we make the square, so we have y square is equal to this first root is removed here due to the square. So we have log x plus square root of log x plus square root of log x plus dash 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 infinity. Now from equation 1, this part we can substitute as a y here. So we have y square is equal to log x plus y. Now differentiate with respect to x. Differentiate with respect to x. So dy square upon dx it is equal to d by dx of log x plus dy upon dx. Now here the derivative of y square it is nothing but 2y into dy upon dx minus this part we are taking to the left here. So dy upon dx it is equal to derivative of log x is 1 upon x. Now take this part common here. So we have dy upon dx. It is in bracket here. 2y minus 1 it is equal to 1 upon x. Finally we take this part to the cross multiplication in the denominator here. So we have dy upon dx it is equal to 1 upon 2 x in bracket 2y minus 1, and same thing that we have to prove here. Therefore proved. Now move on the ninth question here. See, if y is equal to x raised to x raised to x raised to dash 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 and till infinity here, then show that dy upon dx is equal to y square upon x in bracket 1 minus log y. So first we are taking this equation which we given here. So y is equal to x raised to x raised to x raised to till infinity. Now taking log on both sides. So we have log y it is equal to log of x raised to x raised to x raised to x raised to till infinity. Now see, according to the power rule of logarithm, this total power is come ahead in front of this log here. So log y is equal to x raised to x raised to x raised to till infinity into log x here. Right. Now see, if this is equation 1 here, so from this equation x raised to x raised to x raised to infinity, that total part can be substituted as a y here. Therefore, from equation 1, log y is equal to y into log x. Y into log x. Now taking derivative, differentiate with respect to x. So what we get here? D by dx of log y is equal to d by dx of y into log x. So derivative of log y, 1 upon y into dy upon dx is equal to. So by the product rule, y into d by dx of log x plus log x into dy upon dx. So this part which contains dy upon dx, we have to take it left. So 1 upon y into dy upon dx minus log x into dy upon dx. Now here the derivative of this part, that is derivative of log x, is 1 upon x. So we have y upon x here. Now we take dy upon dx common. So take this part common here, that is dy upon dx in brackets 1 upon y minus log x is equal to y upon x. After this, we are doing this subtraction here. So we have dy upon dx in bracket first 1 minus cross multiply y into log x divided by y, that is equal to y upon x. So by cross multiplication here, this part in the multiplication and this part in the denominator here. So what we get here, see dy upon dx, it is equal to y into y square divided by this part in the multiplication here. So x in bracket 1 minus y log x. Now see, this part we have to show there is a some short difference here. 1 minus log y that we require here. 1 minus log y. But what we get? Y log x. Now how to change this part? See here. So as we see this part, see here. This part. So this is y log x. Right? Y log x. And its value is log y. So from this, here we say this is equation 2. So from equation 2, remember this part y log x can be substituted as log y. So finally dy upon dx is equal to y square upon x in bracket 1 minus log y. Once more I am going to tell you here, this part here is substitute like this from equation 1. So hence we prove this. Now we are starting the last question of this exercise 1.3, question number 10 from main question 5 here. If e raised to y, it is equal to y raised to x, then show that dy upon dx, it is equal to log y square divided by log y minus 1 here. So very first, take this part here, e raised to y is equal to y raised to x. Taking log on both sides, taking log on both sides. So we have log of e raised to y is equal to log of y raised to x. Now take this power in front of log. So we have y into log e, it is equal to x into log y. Log e is 1 here. Remember, log e, it is 1. So we have y is equal to x into log y. Differentiate with respect to x. So dy upon dx, it is equal to, here we use the product rule, x into d by dx of log y plus log y into d by dx of x. So dy upon dx, it is equal to x upon derivative of y1 upon y into dy upon dx plus derivative of x, that is 1. So we have log y. Now take this part to the left here. So dy upon dx minus x upon y into dy upon dx. That is equal to log y. Now take dy upon dx common here. So we have dy upon dx in bracket 1 minus x upon y, and that is equal to log y. That is equal to log y. Make this subtraction. So dy upon dx, it is equal to y minus x, into this part in bracket y minus x upon y, and that is equal to log y. After this, take this y in the multiplication and this y minus x in the denominator here. So dy upon dx, it is equal to y log y divided by y minus x. Now see, here we have to resubstitute the value of y here and here. That value we are substituting. So what happens? See, as we substitute, this is equation, suppose that is 1. So from equation 1, we are substitute here in place of y the value x into log y. Okay. So from equation 1 we say x into log y into log y divided by x into log y minus x. So log y square. So x into log y square divided by, when we take this x common here, so x in bracket log y minus 1. So we cancel this x. So finally we get our answer, that is dy upon dx is equal to log y square divided by this part, that is log y minus 1 and root. So here we finish with the exercise 1.3. All you students, revise these questions very properly, and if you like our videos, like our teaching, then please subscribe our channel and like the videos. Thank you.